Hello, this is the Lipid video assignment by Sashank, Pranav, Daniel, Aryan, Matthew, and Josh. On the next slide, we'll talk about our project goals. Our project goals were to develop and evaluate isolation methods that support a mass-based quantification of lipids in snack foods. Secondly, we were to devise tests to verify the absence of non-lipid food components that might interfere with the lipid quantification. And lastly, we were to compare results with other groups analyzing different snack foods, AJ5, 2C7, Y43, to confirm the reliability of our methods and results.
This is the outlines and procedures for Group A. So our overall outline was that we took 3 milliliters of cyclohexane, 3 milliliters of acidic water, and a gram of our crushed snack food into a centrifuge tube. We placed this in the centrifuge, making sure to have a balanced vial of equal mass. And after a little bit, we took out the centrifuge tube and pipetted out the liquid solution that was the top layer. We put this into a beaker and placed the beaker on a hot plate in the fume hood to evaporate the liquid to leave just our lipids. And we recorded the data we observed, and we did this trial 2 more times to gain greater reliability. For our control test, we repeated the steps from the above procedure, and we used the 1 gram of corn oil instead. And because we had expected values of the percent fat by weight should be 100%, but anything above 70 was realistically acceptable. If the percent fat by weight was over 100%, then we know that the sample was contaminated or not all of the liquid evaporated. And another thing is if the percent fat by weight was under 100%, then some of the lipid was likely lost during heating or not all of the solution was pipetted out after centrifugation. For our iodine test, all we did was add the iodine test to our isolated lipid. If it turned a black liquid, then we knew that starch was present. And if starch was proven to be present, then we'd redo the separation techniques that does remove starch. For our procedure validation, we did a protein test. We obtained 5 milliliters of alkaline water and 5 milliliters of cyclohexane. Combined them, we shook them well for 1 minute and let them sit for 3 minutes. If there is protein present, then we would have observed an emulsion. And if there's no protein present, there would be no emulsion.
Okay, and these are the results for Group A. So on the top, we have the results for all 3 trials for the assigned snack, which is AJ5 for us. So we got the mass of the snack and the mass of the isolated lipid for the trial, which led to us getting our values for the percent fat by weight. So for trial 1, our percent fat by weight was 28.78%. For trial 2, it was 21.18%. And for trial 3, it was 24.32%. Now, when we average these 3 values together to get the average percent fat by weight, we got 24.76% in total. Now, for the protein and iodine test, for all 3 trials, we passed them, which means that the values that we got were all actually for the lipids and did not contain any starch nor protein affecting the values. For the control, we ended up using corn oil. And for the percent fat by weight here, we got 91.06% for trial 1 and 90.04% for trial 2, meaning, and since it is above 85% and close to 90%, it means that the procedure was good and the results we got were reliable. And for this as well, the protein test and iodine test, the procedure passed for both of them, meaning that the results are reliable. And in the next slide, we'll go over the actual calculations, an example calculation for each of these. On the top, we have the assigned snack food example calculation. So basically, subtracted the mass of the beaker from the mass of the beaker and the lipid to get us the mass of the lipid. So for the trial 1, it was 15.908 grams minus 15.617 grams. They got 0.291 grams of lipid, which were then divided by the mass of the sample to get 28.78% fat by weight. For the weight of the control test sample, we got, again, we did the exact same thing as in the beginning. We subtracted the mass of the beaker from the beaker and the lipid to get the mass of the lipid. We divided that value by the mass of the sample and got 91.06%. And for the average percent fat by weight, I added all 3 percent fat by weight for the 3 trials, divided it by 3, and got 24.76%. But this value has to be corrected through a correction factor that you get from dividing the mass of the control sample by the mass of the isolated lipid, which was 1.098 as the correction factor. And when we multiplied the average percent fat by weight by the correction factor, we got the corrected average percent fat by weight, which was 27.2%. And that's it for both the results and calculations for Group A.
So as Group B, our assigned snack food was 2C7. In order to isolate the lipid, first we crushed the sample, then mixed it with 3.5 milliliters of HCl and 3.5 milliliters of cyclohexane. We centrifugated the mixture for 5 minutes, then extracted the lipid layer and evaporated it. For the control test, we used 1 gram of corn oil. On following the procedure, we found that the percent fat by weight for the control was 86.17%. Using this, we were able to calculate our correction factor of 1.1604. Next, in order to test for starch, we used the iodine test, in which we added 1 to 2 drops of iodine to the isolated lipid sample. If it turned violet blue, then starch was present, and if it didn't, then starch was absent. For the protein control test, we first measured the weight of the isolated lipid, then added 1 milliliter of nanopure water to the isolated lipid and shook the mixture. We then extracted the lipid and measured its weight again. If the weight had decreased, then there were proteins that had dissolved into nanopure water and the sample was contaminated. Now, on the next slide, we're going to see the results of our procedure. So for our results, you can see that we performed 3 trials for proposal 2. And of them, we found that the average percent fat by weight was 14.83%, as you can see in the table on the top. On the bottom, you can see the results for our control test, where we found the percent fat by weight was 86.17%. However, knowing the control results, we had to correct for our procedure. And thus, we calculate our corrected weight, which was 17.2%. And we found that there were no starch or protein present within our isolated lipid sample either.
For group C, we used snack Y43, and our procedure to do so was we crushed the assigned food sample until it was a fine powder, and we weighed out approximately 1 gram of the snack. We put this 1 gram into a tube and measured out 3 milliliters of cyclohexane and 3 milliliters of acidic water. Then we used a centrifuge to mix the solution until there are distinct layers. Using a transfer pipette, we took out the top layer, which was our lipid layer. Then we evaporated the solvent to get the lipid isolated and found the mass. We then repeated this for trials. For our control test, we started off with approximately 1 gram of our control, which was coconut oil, and we followed the same procedure. And the percent lipid that we found by weight was our correction factor used. For testing for starch, we placed 1 drop of iodine in the isolated lipid sample, and we saw if it changed color. And if it didn't become dark, then the starch was removed successfully. To test for protein, we added 2 milliliters of cyclohexane, 2 milliliters of acidic water in the isolated lipid. We mixed and observed if there was any protein visible near the bottom. If there was, then the protein wasn't properly extracted. And next up, we have our results for Group C. For the 4 trials, we found that our average percent fat by weight was 17.68%. And the iodine and protein validation tests proved that there wasn't any starch or protein. And for our control group, we found that our percent fat by weight was 85.03%. And both the tests were negative too, showing we didn't have starch or protein. And next up, we have how we did our calculations. For our trial 1, you can see how we did our calculation to get the 23.53% lipid. And below we have our control group doing the same exact equation. We found 85.03%. And then we took the average percent lipid dividing by the correction factor to get 20.79% as our adjusted percent fat by weight. And next up, we have our comparison.
So for the comparison, we have the percent fat by weight in the assigned snack, which was 27.72% in Group A, 17% in Group B, and basically 20% in Group C. The percent fat by weight in the control was, and that was for the assigned snack. For the control, it was 90.6% in A, 86.17% in B, and 85.03% in C. And they passed the protein and iodine test. There were three similarities. The first was they all pass a protein iodine test. The results are reliable. They don't have any starch or protein. The second is all the percent fat by weight values were within a range of 15 percentage points. So they're all pretty similar. And they all had similar results for the control test, all above 85%. So there's a good amount of validity behind all the results. But the difference is, one, we all had different snacks, AJ5 to C7 and Y43. So obviously it's a big difference. Second is we all had different percent fat by weight values. So even though they are within a certain range, they are different values. So there's a main difference. And we all use different controls. Group C used coconut oil, while group A and B both used corn oil. So that's also a major difference between the values.
All right, so all three groups said that they were confident in their procedure and their results because they got similar values across their trials. They also all got high values for their confidence when they did their control test. And all three groups agreed that the ways they could improve it was to be more careful with the pipetting, with using a micropipette or measuring the volumes more carefully. Group A also said to use a centrifuge multiple times and use a larger beaker when heating the lipid solution. Group B said to allow the lipid mixture to evaporate for a longer time. And Group C said make sure that the whole sample was put into the tube without any small crumbs falling out, and compare results with another group that has the same assigned snack.
The reflection, the concepts we learned through this project are solubility, centrifugation, understanding macronutrients. We learned that solubility and how to separate different molecules, and this can be applied to practical purposes in our life by understanding composition of different foods to make a plan for nutrients, which applies to everyone in our world. And we can learn to separate other miscible liquids from fatty acids and chain oils, which is very important for nutrients and all the food that we eat, because everyone eats food. And that's it for